Now let's discuss how we can use GIS to analyze geospatial data. That is, analyzing geographic and feature attribute information, where we measure, classify, and query it, or perform proximity, overlay, connectivity, and even custom analysis. Now, the first category of geoanalytics we'll explore are those that measure or calculate the geometric properties, summary statistics, or geostatistics of geographic information, including calculating the geometric properties like the X, Y, and Z coordinates, or maybe length, area, and volume, summarizing the attributes by values so that we can look at value distributions like histograms or standard deviations, or even calculate general statistics like count, min, max, sum, and mean. We can also measure or describe data with geostatistics by calculating the spatial distributions like standard deviational ellipse or mean center, or even hotspots, outliers, and clusters. If you look at the example on the right, I'm using ArcGIS Online, which is a cloud-based GIS software to not just map, but analyze data as well. In this case, Texas wind turbines. In the image on the right, you can see that I've filtered for only those turbines in Texas, and then I performed a geostatistical analysis that calculated one standard deviational ellipse from the mean center. And so I've generated an ellipse that captures roughly 68% of all wind turbines in Texas. And so this analysis tells us that most of Texas's wind turbines are located on the high plains. Another category of geoanalytics are those that classify or group geospatial data by unique values, numeric range, or location. And we can do that qualitatively by classing descriptive, nominal, or categorical values and grouping them by unique value, or quantitatively, in which we group numeric, ordinal, interval, or ratio values by range. We can also summarize by location, where we aggregate cells into larger cells or points into clusters, polygons, or bins. And then we can statistically summarize the values for those aggregations. Building on our previous analysis of Texas wind turbines, I've symbolized the turbine points by total capacity or megawatts so we can see those turbines that have larger wind energy production. I've also aggregated the points into hex bins and calculated the total capacity that falls within each of those bins. Another method for analyzing geospatial data are queries, where we search and retrieve tabular records in geographic features or cells. And we do it by performing either attribute or spatial queries. Attribute queries select records based on an expression, and then you can analyze the selected subset of records and features or cells. Spatial queries select features based on a spatial relationship. And again, you can analyze the selected subset of features or cells and records. In our Texas wind turbine analysis, I've run a type of attribute query called a filter, in which I've filtered Texas wind turbines by the model of turbine, in this case, a GE 2.8 megawatt turbine. Proximity geoanalytics analyze relationships between nearby features or cells to create new data. And we can either calculate values or construct new geometry. If we calculate values, we might, for example, calculate distance or density by running a geoprocess like near or kernel density. To construct new geometry, we might create new layers from adjacent or nearby features or cells through geoprocesses like buffer or interpolation. For our Texas wind turbines, I've analyzed proximity by calculating the density or creating a heat map of our turbine point locations. And you can see the results of our analysis show, again, that most of the Texas wind turbines are located in the plains area, but also north in the Panhandle and south along the Texas Gulf Coast. Overlay geoanalytics analyze relationships between overlapping features or cells to create new data. And again, we can either calculate values or construct new geometry. If we're calculating values, we might join or calculate new values for overlapping features or cells using geoprocesses like spatial join, enrich, or map algebra. If we construct new geometry to create new layers from overlapping features or cells, we might use geoprocesses like intersect, union, or raster overlay. In the Texas wind turbine analysis, I've used the enriched geoprocess to add the number of 2024 transportation and warehouse businesses that are within 30 miles of each turbine in Texas. You can imagine using this to figure out where you need to warehouse extra blades or turbines to service your windmills. Connectivity geoanalytics analyzes the relationship between connected features or cells to create new data. And like the other computational geoanalytics, we can either calculate values or construct new geometry. So to calculate values, I might join or calculate new values for connected features or cells through geoprocesses like origin destination cost matrix or distance accumulation. To construct new geometry, I might create new layers from connected features or cells with geoprocesses like new route or optimal path. In our Texas wind turbine example, I'm looking at turbine locations in and around Corpus Christi Bay. And imagine how we might route somebody to inspect a certain number of turbines in a single day. And so in ArcGIS Online, I'm using the Plan Routes Cloud Geoprocessing tool to identify the most efficient route and the number of turbines that can be visited in a single day. Now, in this and previous slides, I've talked about a lot of different geoprocesses. We're going to spend all semester talking about vector, raster, and 3D geoprocesses. So I don't really want you to memorize the geoprocesses themselves, but I do want you to be able to describe the different categories for geoanalytics that we use in GIS. And last, custom geoanalytics analyze spatial relationships between features with custom tools. And you can see I've listed out a number of different industries in which custom geoprocessing and analysis tools have been developed to support those industries. For example, in aviation, for identifying obstructions, in cartography, creating overpasses and underpasses, in crime analysis, processing cell phone records, for example, in maritime, smoothing bathymetric tins, all the way down to customized tools, models, and scripts. And it's what I really love about GIS because it's been around for a while. And odds are, if you're working on something in a specific industry and you cannot find the tools that you need to accomplish the task, you can either search within that software or even online, and you can find customized tools, models, and scripts that will support your industry-specific geoanalysis.